In this video, we're going to talk about elimination, and that's a way to solve for a system of equations where you eliminate one of the two variables. Here's how it works. Let's say you have these two equations and you want to solve for the system. Well, here's a separate point here, how this thing works and why it works. If you have an equation, right, and you want to add something, well, you can add something to the equation as long as you add the same thing to both sides. Same with subtracting, anything. That's the whole point of equations, right? They're equal, and you got to do the same thing to both sides. So here's a crazy thought. What if we added this equation to this equation? First of all, it only works if you add the same thing to this side as you do to this side. But here's the thing. Since this is also an equation, we know that 5x plus 2y is really equal to 27. So I'm allowed to add 27 to both sides of this equation, right? Except maybe this 27 looks a little different. It looks like 5x plus 2y, because guess what? 5x plus 2y is 27. So what I'm going to do then is this. I'm going to add 27 to both sides of that first equation, but the 27 that I'm adding to the left is really going to be the left-hand side of this equation. It's going to be 5x plus 2y. So here's what that looks like. So just so you're really clear, the first time we do this, this left-hand side is now going to be, we started with negative 5x plus 4y, and we added this thing over here, the 5x plus 2y. And on the right-hand side, we have 9, and then we added the 27. So let's add this. So 9 plus 27 here is just going to be 36. And over here, let's see, you could sort of combine like terms, right? This negative 5x and the 5x, hey, they add up to 0. They are eliminated. And as we'll see, that's the whole point of this. You're going to set it up where they get eliminated. And here you got this 4y plus 2y, which is 6y. So let's take stock of what we just did here. We basically added the second equation to each side of the first equation. And once we did that, the x's got canceled, and the equation just became this really simple 6y equals 36. That's really easy to solve. Divide both sides by 6, and you just get y equals 6, right? Because 36 divided by 6. And then, of course, you could plug it back into either of the two equations and figure out what x is. So I'm not even going to worry about that for this. But basically, one thing I want to note is that here, there's a quicker way to do it than writing it all out. So that other equation was 5x plus 2y, right? This is how the original setup was. So when you're adding this, I know that I'm essentially going to pair these like terms together. That's why you'll often see people, they're just going to almost set it up like this. They're going to align the x's with each other and the y's with each other because they're the like terms that are going to be combined. And you could just look at this and say, oh, if I'm adding this guy plus this guy is 0, eliminated. 4y plus 2y is 6y, and this is 36. So this is how quick it can be. Let's look at another example. So here, first of all, here, this 2x and this 2x, so again, we're already thinking ahead. Here, adding the same thing to both sides is just one of the options. The other option is subtracting the same thing from both sides. So here, if I subtracted this whole equation from this first equation, let's see what we get. Now, here's where we got to be really careful with the signs. So if you're going to do the subtraction, you could do, again, what we're really doing is this whole thing minus this whole thing is what the new left-hand side is going to be. But again, we're going to look at the like terms. So this is going to be 2x minus 2x. So that's 0. But then for the y's, it's going to be 3y minus negative y. And minus negative is adding. So this is really 3y plus y, because minus negative. So that's 4y. And here again, we're subtracting. So it's 10 minus the negative 6, which is really 10 plus 6. So that's 16, which leads us to this. And then we just divide both sides by 4, and we get y is equal to 4. And then again, if you just wanted to be sure, you can always plug it back in. So let's say we just plugged it back into this equation. This is just 2x minus y, which we now know is 4, is equal to negative 6. And you can easily solve this by adding 4 to both sides to make that a negative 2. And you just have 2x left here. Divide both sides by 2, and you get x is negative 1. So that's how you can do that. You could also have plugged it into this one, whichever you prefer. Notice there is another way to have done this problem. If you really wanted to, what you could do, and we'll look at this in the last example, but really, if you're somebody who prefers the whole adding, so let's just do really quickly for this one. If instead I had taken this guy and said, you know what, I really don't want to subtract, what you can do is you could take this equation and multiply both sides of this equation by like -1. If you do that, then let's see, then the second equation just becomes -2x plus y equals +6. And then in that case, now when you add this equation with this equation, it becomes a lot easier to manage because adding this plus this is 0, adding this is 4y, adding this is 16. So that's your choice how you want to do it. Finally, one last example where we're going to have to use that technique again. Here, basically, what we want is to, again, make it where when you line up the x's and the y's, it's something easily is eliminated. You either want to make the coefficients exactly the same, like we had in the first example, or like we had in this example, the 2x and the 2x, or you want to make them opposites. So let's see here. We could do something with the x's if we really wanted to, multiply by 2/5 or something, but it's probably easier here to focus on the y's. So if only there was a 7 in front of this y, then we can line these up and 7y and -7y add up to 0. So notice you don't have to eliminate the x like I did in the first two problems. You can also eliminate the y. But so man, if only this problem had a 7 in front of here, it could work. So how do we get a 7 in front of there? Legally just multiply both sides of the equation by 7. So if we do that, this second equation is transformed to, let's see, 7 times 2x, that's going to be 14x. And then 7 times -y is -7y. And on the right-hand side here, 7 times 12 is going to be 84. So now I'm just going to erase this one just to put it out of our memory. So bam. So these are the two equations that we're now working with. And all we got to do is add the second equation to the first equation. So that's how easy it is. So let's, again, we could just add the like term. So what's 5x plus 14x is 19x. What's -7y? 7y plus -7y, 0. That was by design. So the left-hand side is just 19x. And the right-hand side, 84 plus 11 is just 95. And then finally, to solve for x, just divide both sides by, I guess, 19. So 95 over 19, which actually is just 5. And again, you could use your calculator to figure that out if you wanted. And then you could just plug it into either of these two equations that at this point you guys are really comfortable doing, so I'm not going to waste your time doing it. But once you got that x is 5, you could just plug it into this and you should get that y is -2. But either way, that's how you can solve for a system using elimination.